Hello dear friends, myself Sonigra, and today we are going to discuss the solution of GTU examination question paper in the subject of mechanical drafting. The question paper is taken from the exam December 2013, that means last exam, and previously we solved the same question paper up to question number 3A. Today we will continue from question number 3B. The question number 3B is given like this. Draw the development of the lateral surface of the cylinder of 50 mm base diameter as shown in figure 2. Here figure is shown like this, and we have to draw the development of its lateral surface of given cylinder. The height of cylinder is given as 70 mm, diameter is given as 50 mm, and two cuts are given here. One cut is at an angle of 30 degree and another is at an angle of 15 degree, and an arc is cut with radius 20, and we have to develop the lateral surface of this solid. This is the solid cylinder, given solid, and to draw two views of this cylinder, it should be drawn like this. In top view it would appear as a circle, and in a front view it would appear as a rectangle, and it could be drawn like this. The diameter of the cylinder is given, that is 50 mm. So draw a circle of diameter 50 mm, insert the dimension diameter 50 mm, then draw projection lines from the ends, and then draw a rectangle having height is equal to 70 mm, which is given in the data. This is the given data which we are drawing. Height 70 mm, width is equal to 50 mm. This is the axis of the solid, or the center line of the circle, and divide this circle, this top view, into equal number of parts. It's needed, this one, because the cylinder is not having any outer surface or outer edge. It's needed to divide into equal number of parts. Suppose here it is divided into 8 parts at an angle of 45 degree. Name each points on the periphery of the cylinder, that is A, B, C, D, E, F, G, H. Now, as we know, if we develop the outer surface of the cylinder, it would be a rectangle as shown over here, like this. Outer periphery of this cylinder would be a rectangle having width is equal to the periphery of the circle and height is equal to 70 mm. Like this. Suppose this is a cylinder, you can see here, we can make a cylinder like this, in which the top view is circle and front view is a rectangle that we have drawn. If I develop its outer surface, if I open it, then it would appear as a rectangle like this, and width of this rectangle would be equal to the periphery of this cylinder. Now how to draw the next step? After drawing this rectangle, we have to divide this circle into equal number of parts, and these same divisions should be transferred to this rectangle. So for that, let me draw this exercise on the drawing sheet. Here this is given data, this is cut portion, this angle is 15 degree, which is given data, this angle is 30 degree, that is also given data, and here arc is drawn, it is cut with radius is equal to 20 mm, and draw a rectangle to the right side of the given cylinder having width is equal to pi into d, that is 157 millimeter, and height is equal to 70 millimeter. As the circle is divided into 8 equal parts, this rectangle should also be divided into 8 equal parts. So for that, first let me divide into 2 equal parts, again into 2 equal parts, again into 2. So that is the 8 equal division of the developed portion of the cylinder's lateral surface, like this, and name each points from 1 to, this is point number 1, 2, 3, 4, 5, 6, 7, 8 and back to 1. In examination you can use ball pen, but in a drawing you should use pencil only. Now let me pick up here point number 1 is here, and let me pick up this cutting plane. To transfer the points on this cutting plane or the periphery of the circle to this development, let me pick up one point. This is point number 1. So draw here generator 1 dash, that is imaginary generator drawn over the outside surface of the cylinder. This is point number 1 dash. Similarly, here is point number 2 dash, here is point number 3 dash, here is 4 dash, 5 dash, 6 dash, 7 dash and 8 dash, and so on. Now find out point of intersection between generator 1 dash and this cutting plane. So that point is here. So transfer that point to 1, vertical line from point 1. So this is our first point, right? Now to find out another point, this is generator 2 or 2 dash. So from that point draw a straight horizontal line and transfer that point to point number 2. Here vertical line from point 2 is here. So transfer that point. So this is the point which we have here. Similarly, point number 3 is here on 3 days. 3 is here. So 3 days, from this point draw a straight horizontal line that will cut vertical line from point 3 at this point. Similarly, point number 4 days is here. So from this point draw horizontal line. Here is point number 4. Point number 5 is at the top over here. So point number 5 would be here. And with the same analogy, on this side also we can pick up rest all points and join all these points with the smooth curve. So that would appear like this. Similarly, on this side also points would be there, 1, 2 and so on. So join all these points with the smooth curve like this. So this is the development of this cut portion. It starts from here and ends to here. In development, the first line and the last line will have identical points that we have drawn. Similarly, for this portion or this bottom cut portion, pick up points one by one. Here point number 1 is here. On 1, point number 1 is here. Transfer this point. This is our first point. Similarly, second point is here. So draw horizontal line from this point. That will cut vertical line from point 2 at here. So that is second point. Similarly, point number 3 is here. On 3, from here draw horizontal line that will cut vertical line from point 3 at this point. Similarly, point number 4 is here. Draw horizontal line. So here is point number 4. Point number 5 is here. So here is point number 5. Similarly, 6, 7, 8 and back to 1. And join all these points also with the smooth curve. Whenever curve or cylinder is given, cone or cylinder is given, cutting portion would be curvature shape in case of development. That is exceptional in case of helix. If helix angle is there, then straight line would be there. But normally the development of any curvature surface solid would be curvature shape. So these are the two surfaces which we have drawn, this upper one and this lower one. So till now we have finished this portion. You can draw here line to show that we have drawn up to this end. This also we have drawn. Now we have to worry about this circular arc, this arc which is given in the data. So for that, what should we do? So for that, first we know first 2 points, that is upper point and lower point, are known to us. So we can transfer those 2 points directly to the developed portion like this. One point is here, another point is here. So draw horizontal line from here. So this is first point, horizontal line from here, this is another point. So 2 points over here, similarly the same 2 points would be on the last column. One point is here, another is here. Now here the point of intersection between this arc and imaginary generator 2 days and 8 days. Here two generators are there, 2 days and 8 days over the outer periphery of the cylinder. So pick up those 2 points. Here is point number 1, here is another point. So from these 2 points, draw straight horizontal line that will cut O2 or vertical line from point 2 at this point, and from here at this point. Transfer this point to here, so this is the point. Similarly, here imaginary generator 8 is also there. You can see here, this is imaginary generator number 8. So for that, transfer this point to 8. 8 is here, one is here, another is here. So we have picked up both the points on 8 as well as on 2. Now what's about this end point? It's a very critical to find out the position of this point, and for that let me transfer this point to its true position. So for that, from this point draw a straight vertical line that will cut the cylinder at 2 points. One point is here between C7 and 8 and another point is here between 2 and 3. You can highlight this, but in exam it would not be needed to highlight these 2 points. Now we know position of this point, that is true position, that is between 7 and 8 at this distance. To have precise measurement of this point, we can measure this angle. Join this point with the apex point O and measure this angle, and according to that angle we can find out the position. But here with just estimation or lump sum, we can put here point between 7 and 8. It is nearby 7 and 8, somewhere here. So from that point draw a straight vertical line, because here that much accuracy is not needed, hence we can directly transfer the point over here. Similarly from point 2, between 2 and 3, towards 3 the point is there. So towards 3 you can draw here straight vertical line or one more imaginary generator over the outer periphery of the cylinder. Now transfer this point to this vertical drawn line. So from here draw straight horizontal line that will cut this imaginary line over here. Similarly this imaginary line over here. So we have picked up those 3 points also. Now join all these points with a smooth curve, so that would appear like this. In examination you should not use sketch pen, you have to use pencil only, like this. And to differentiate between the actual solid and the projection line, you should use light colored pencil and dark colored pencil. In this examination, in this example, this portion covered by this is the solution of the problem. You can write here, this is the development of given cylinder. If the cylinder is cut like this, this would be its development. I hope the solution of this problem is clear to you. These points are very critical. Now how to find out the precise position, that we discuss that thing. So for that you measure this angle. Join this point with apex point O, like this, right? We need to find out this angle. We can compute, suppose total length is pi into d, that is equal to 50 into diameter is pi into 3.14, that is 157 millimeter. Total width is 157 millimeter. So we can write like this, 157 millimeter is equal to 360 degree, or 360 degree is equal to 157 millimeter. You can write like this. Of course in examination you need not to write all this calculation. Just for the knowledge we are discussing this matter. 360 degree is equal to 157 millimeter. Then what should be this angle? Theta. Whatever we measure this angle over here, theta means how much millimeter. So measure this distance, that is theta into 157 upon 360, and this length will be the length equal to distance between point number 3 and this point, say P. So this distance 3 and P would be equal to this distance. As far as our examination is concerned, it's not needed to have such precise accuracy in this problem. I hope the solution of this problem is clear to you. Now next problem, question number 3a. asked in option, the data is given like this. A cone base diameter 50 millimeter and axis 70 millimeter long is resting on its base on horizontal plane. It is cut by a sectional plane which is parallel to vertical plane and 10 millimeter away from the axis of the cone and near to the observer. Draw the plan and sectional elevation of the cone. Here the cone is given. This is the cone which is given in the data, and its top view and front view would be drawn like this. Draw XY line that represents intersection of HP and VP. This is top view, that is circle, and this is front view. So this is given data, top view and front view of the cone. Top view is a circle, front view is a triangle. The dimensions are known to us. Here the given data is like this. This cone is cut in such a way that the cutting plane is parallel to vertical plane, means the cutting plane would appear as a line in top view because it's a parallel to vertical plane, and this cutting plane is at a distance of 10 millimeter from the axis of the cone. This is the cone and axis is here. So from this axis the cutting plane should be drawn in such a way that it becomes parallel to XY line and at a distance of 10 millimeter from the axis. So it should be drawn like this. This is the cutting plane axis. It is parallel to vertical plane, that is XY line in case of top view, and the distance between this axis, means this horizontal line, and this axis is 10 millimeter. Now how to draw this cut portion in drawing sheet, that we are going to discuss here. So for that, let me draw a given cone. Here cone is given like this. Diameter of the cone is known to us, that is 50 millimeter, and height of the cone is also given to us. So this is the cylinder cone, top view of the cone, and to draw its front view, let me draw its axis from here. This is the imaginary generator drawn over the periphery, and from here we can locate its center line, or you can draw directly lines because